Okay, so as it says here in this lesson, you will use isosceles triangles and trigonometry to find the area of a regular polygon. We're going to do an example problem that's like a warm-up. And you'll see that you're just using a whole bunch of things that you already know. Now, it says you can use trigonometry to find the area of a regular polygon when you know the length of a side, the radius, or the apothem. Typically, what we're going to be finding is length, because in order to find area, you're using length measurements. So here's an example that they've given you. The pendant at the right is shown in the shape of an isosceles triangle, and the measure of the vertex angle right here, this pointed end right here that's not equal measure base angles, is 20. What's the area of the pennant? How do you know? Okay, so I'm going to make a sketch of this using my drawing tool. And now we've got it kind of standing up so that it looks a little bit more like something that maybe you're used to solving for, like an isosceles triangle, the way you usually see it. And if this is 20 up here, I'll write it in here. Okay. Then we're going to use, when we do trigonometry, very often, not all the time, as law of sines and law of cosines shows you, but very often we're going to be using a right triangle. So what I'm going to do here is I'm going to drop this apothem down. And when I do that, you know that you're splitting this vertex angle up equally into two equal measures, that we're really now we have half of this triangle. So if I was to sketch that over here, just the one side of it, and that. Okay, you can imagine this is the one half of this triangle, and now we've got this angle, we've got this angle up here of 10 because we split that 20-degree angle in half, right? And now we're dealing with a right triangle. And since this is a right triangle, we've got a base angle. This right here says this is 10 inches. And if I could have written that in here as 10 inches. But now since we split it in half, we've got this side being 5 inches. We want this, and we have a 10-degree angle up here. So what two sides do we have in relation to this 10-degree angle? Okay, we have the adjacent side and the opposite side. The hypotenuse is obviously opposite the 90 degree. Okay, so opposite and adjacent is tangent, so we can write the tangent of 10 degrees equals the opposite side length, 5 over the adjacent side of x. And I taught you this trick where you can actually, if this value is on the bottom and you want to swap it with the position with this value, they can swap by multiplying this by x. So it says x times tan of 10 degrees equals 5, and then dividing by tangent of 10. And so what we get there is x equals 5 divided by the tangent of 10 degrees, and that's what we want to use our calculator for. Okay, so we say, let's see, 5 divided by tangent of 10 degrees equals, and we get 28.35 as that side, 356. So I'm going to round it to 28.4 approximately. So now we have 28.4 inches approximately, and if we were using this area of this, we would say 1/2 base times height. And if the area equals 1/2 the base of 10 times the height, actually I'm going to put approximately equal to because we have an approximate measure for the height, times the height, 28.4, we get an area of the pennant approximately equal to 142, and the units was inches, so they are inches squared. Okay, what I did there is I needed to find the height of the triangle, and we did that by using trig, splitting this in half. So we had a right triangle, half of that base then, and then we know half of this angle of 20 would be 10, and we can use the tangent function to find that, and then use the area formula. Okay, that maybe took a bit for a warm-up, but that will give you the real big ideas of the lesson. So here, let's go and let's start attacking the problems that they're giving us. And how do you know? Okay, so the first problem, very similar to what we just did in terms of finding the area of a triangle. What is the area of a regular nonagon, 9-sided, with 10 centimeter sides? So you see that they're giving it a 10 centimeter side. We've got a 9-sided figure. Okay, and what are we trying to do? Well, we're trying to section this off. Since it's a regular nonagon, we know that from that center to each vertex is going to be the exact same length. We don't have that distance, but we're not really worried about it anyway. What we want to find is the apothem. Okay. What is the apothem? The apothem is the altitude of that isosceles triangle right here, because then we're going to do 1/2 base times height, right? And the apothem bisects the central angle. This is the central angle right here, and we can find that by saying there's 9 equal angles there. Okay, so we can find that angle, and then this side is 10. It's going to also bisect the side of the polygon, so we will get 5 there. So let's look at what it says for this. Okay, draw a regular nonagon, because we're assuming that we didn't have the drawing to begin with, and they're saying first start by drawing it, give it a center C, and now you're going to draw CP and CR, two adjacent vertices, right? Connect them to the center, and that will form the isosceles triangle. Oops. PCR right here. Got that triangle, okay? And the measure of that central angle, if there's a whole 360 degrees here and there's 9 equal angles, you do 360 divided by 9 and you get a 40-degree central angle here, okay? Now, the perimeter is 90, 9 sides times 10, and we need to know the apothem, because the area of this is going to be, remember what we did? We did 1/2 the apothem times the perimeter. And again, I'll write that out for you to make sense of it if you don't remember it from the lesson that we did earlier. Okay, so first thing we want to do is we want to have that apothem here, CS, and notice this. Okay, if we said PCS right here, this triangle right here is going to be half of PCR. This was 40, right? So that'll be 20, this if we split it in half. And half of the side length of PR of 10 would be 5 here. Okay, what you get then is you get this triangle right here. We have that 20-degree angle there and this side of 5. And what we're looking to do is solve for the apothem. You should hopefully remember the formula is for the area of a polygon like this, a regular polygon, is 1/2 the apothem times the perimeter. Okay? Because, and I'll write it here and then erase it, area equals 1/2 the apothem times the perimeter. And what is the perimeter? The perimeter is just the side length times the number of sides. Okay? So if you were to find the side length here times the apothem times 1/2, you'd find the area of one of these triangles. This part right here gives you the area of one of the triangles. Multiplying it by the number of triangles, the number of sides, will give you that 9 times to give you the whole area. Okay? So that's a formula that you want to use. Okay, thanks for your patience. Now, let A right here represent that apothem of CS. Okay, we're calling it A for apothem. Find A and substitute it into the area formula. Well, the first thing we have to do to find it is we say, okay, if we have this angle of 20, right, and we have the opposite side looking for the adjacent side, we have tangent for opposite and adjacent. Tangent of 20 equals the opposite, 5, over the adjacent A. And Solving that out, remember those can switch places. So you have the a over here and the tangent of 20 there. Solving for a, and then this is just a calculation that you make. But they're saying, look, you can just plug that straight in and we can calculate it all together. Okay, so since the formula for area of a polygon is 1/2 the apothem times the perimeter, here's the 1/2. Here's the apothem in terms of the tangent function, which is, by the way, this is just a number and so is this, so this will work out to just be a number, okay, times the perimeter, which we found out sides are 10, there's 9 of them, total of 90. And then when you calculate that out using your calculator, you get approximately 618 point blah blah blah. Okay? And so the area of that regular nonagon is about 618 square centimeters. And this is a key feature of this. Let me circle it, that you're going to be using this formula here. Okay? So that's how you do it. We've got a got it problem on the next page for you to see if you can apply this. So they're asking for the got it problem, what is the area of a regular pentagon with 4-inch sides? Round your answer to the nearest square inch. You're going to sketch this, and then you're going to do the necessary calculations and find the area to the nearest square inch. You can go back and see what I did on the last slide. You're going to pause it right now, and then you're going to solve this and unpause it when you've got your solution. Okay? So pause it right now. Okay, so I'm going to draw this regular pentagon, or best that I can. And we've got this center here, okay? What we want to do, if we have sides of 4 inches, let me label it, 4-inch sides. Then if we draw this, well, first of all, we connect these two vertices. Let me do it with a different color here. Let's connect these two vertices. And what would this central angle be? Well, if we have 5 equal triangles and it is 360 degrees all the way around, then what we've got here is a 72-degree angle up there. Yeah? Now, of course, what we're trying to find is the apothem, this height right here. So if we were to take one section of this triangle like this piece of it right here, then we no longer have 72 degrees at the top. Now we have 36 degrees. Put that in here. That's 36 degrees. And we no longer have an entire 4-inch side down here. We've got half of that, and we have a 2-inch side. Okay? We're looking for this height right here, the apothem height. And you can see that there's a theme going on here. What are we using? We're using tangent because we have the opposite side. We're looking for the adjacent side. So we can write that out as the tangent, the tangent of 36 degrees equals the opposite side 2 over the adjacent side x, and solving for that we switch it and we say then that means that x equals 2 divided by the tangent of 36. Don't be this guy that thinks that they can somehow simplify 2 over 36 to 1 over 18. It does not work that way. Don't do that, okay? You have to do these separately. Don't do that, because this 36 is not just floating out there loose. This is a number that is the tangent of 36. Sorry, it got a little glitchy there. Anyhow, this represents the apothem height, x here, this right here. Okay, so if we did, the formula for area of a pentagon is the area is equal to 1/2 the apothem times the perimeter. Then we can say, okay, that is 1/2 of 2 over the tangent of 36 times, and what is the perimeter? Well, the perimeter is 5 sides of 4 each, or 20. Okay? Simplifying this out, we can multiply everything across the top. We can say 1 times 2 is 2, 2 times 20, because that's like 20 over 1, right? 1 times 2 is 2, 2 times 20 is 40 on top, over 2 times tangent of 36. And this you can cancel. This you can cancel. This 40 and this 2 are just numbers, so you can cancel those. And we get then 20 over the tangent of 36. And when we find this, and of course it'll be rounded, so it'll be an approximate number, we will have found the area of this. So I'm going to type into my calculator, 20 divided by tangent of 36, and I get approximately 27.527. That's all I need there because they're rounding it to the nearest square inch. So we can say then it's approximately equal to that 5 there in the 10th place rounds up to 28. Nearest square inch, 28 inches squared. That's our answer. Okay, so we're going to have to do the solution on a different page. We don't have enough room for it because it's pretty long, but hopefully it all makes sense. Here it is. A stop sign is a regular octagon. The shape of it will matter because that'll determine the central angle and all kinds of things. Okay, and the standard size is a radius of 16.2. That is not a side length, but that is from the center to one of the vertices. So that's going to end up being the hypotenuse of the triangle that we'll make. Okay, what is the area of the stop sign to the nearest square inch? We know the radius, 16.2, and the number of sides, 8. We need the apothem and the length of a side. The length of a side will be able to determine the perimeter, and it's 1/2 the apothem times the perimeter for the area of this. So we're going to use trig to find the apothem and the length of the side. Okay, we'll do this on the next slide. It looks like a lot, so we'll go step by step. Check it out. Okay, so what we've got here just on the side is we've got this octagon, and we've got what we know. How do we know that this is 22.5 degrees? Well, check it out. If we have 8 triangles that come from connecting the vertices, right? However many sides there are, you're going to get a triangle for each one, each side being the base of one of them, okay? And so if you do 360 degrees divided by 8, you're going to find that each central angle is 45 degrees. And then we were going to cut it in half by drawing an apothem down here, okay? So let A represent the apothem, and we're going to use cosine to find A. Why cosine? Well, first let's watch what we know, okay? We know that the central angle is 360 degrees divided by the number of sides, or 45 degrees. We know that each central angle is 45 degrees. Now, the measure of angle C up here is going to be half of that, because when we drop the apothem, it cuts it in half, and it cuts the side length in half as well. We don't yet know what the side length is, but we know that this angle is 22.5. Okay, so we can set it up to find the apothem by saying, okay, if we have this angle, we're looking for that side. We know the hypotenuse. This is the adjacent side for that 22.5 degree angle. Adjacent and hypotenuse is cosine. So the cosine of 22.5 equals the apothem over the hypotenuse of 16.2. Multiplying both sides by 16.2, you will solve for A, and you will find out that the apothem, this is the length of the apothem here in terms of the numbers that we've got. Okay, now step 2, we're going to let X represent that segment of AD right here, and forget about A right now. We're just using this angle. We've got the opposite side and the hypotenuse, so that's sine. So sine of 22.5 equals the opposite side x over the hypotenuse 16.2. And of course, multiplying both sides by 16.2 to clear it off the bottom here and leave you just with x, what x is equal. You do that, and now you know that x is equal to that. Okay? Now, those are numbers that we'll use in our calculations in a minute. So we don't need to resolve that any further. Why don't we do it now? Because this is going to round off. And once we round off, we don't know what other kind of multiplication we're going to do to it. And a small amount rounded off could become a big amount if we multiply it by something big. So we're leaving it as an exact value for right now until we plug it into our calculations. Okay? So we found this length here. We found the apothem. What we need is, remember, the area of this is 1/2 the apothem times the perimeter. So we're going to use this, what we just found, to find the perimeter. So step 3, find the perimeter. We say the perimeter is just the length of a side times the number of sides. It's an octagon, so there's 8 sides. What is the length of a side? Well, we know right here that half of the side is what x is, right? So 2x is going to be equal to the full side length. And this is a formatting error that says the length of each side is 2x. Okay, so we get 16x for the perimeter, and what we're going to do instead of for x, we know what x is equal to from up here, this past step, so we're going to plug that in here, and you can actually just calculate this out. And that's what the perimeter is equal to. So we now know what the perimeter is. We know what the apothem is. We know what the perimeter is. So I'm going to circle that as well. Okay? Because that's what we need to do our calculations. So then we say, okay, step 4 is to substitute into the area formula. The area formula is 1/2 the apothem times the perimeter. The apothem is up top. 16.2 times cosine of 22.5, and the perimeter is 259.2 times the sine of 225. Again, we didn't calculate what these are because they would necessarily be rounded, because we can't write all the digits out, that it would go on forever. So what we can do though now is we can type all of this into the calculator. I'm going to type into the calculator and say what I got. I didn't see the result because it's still hidden under there. So I'm going to do it, see if my calculator comes up with it. So I'm going to say 1/2 times 16.2 times cosine of 22.5, close that parentheses, that's very important, times 259.2 times the sine of 22.5. And what I get is 742.2924126. Okay, so let's see what they've got. 742.29 something. And they say then the area, 742.29 something something. Since they told us to round it, maybe they did, I think, round it to the nearest square inch. The area is this number, rounded to the nearest square inch, or about 742 inches squared. Okay, that looks like a super complicated problem, but really, essentially, all you're doing is you're saying, I know what this, I can figure out what this central angle is by saying 360 divided by however many sides there are. That'll give me that central angle. The apothem will split it in half. So we've got this measure of this right here, and what we know the radius. So what we're finding is this. That's the apothem that will go into this formula here. And then if we find this, we can say twice that amount is one side times however many sides, and that'll give us the perimeter, and that we can plug into the other part of the formula. Okay, so it looks like a bunch of work, but it's pretty straightforward. Let's do the got it problem for this. Okay, so here's the got it problem, that you have a tabletop that's shaped like a regular decagon. If you don't know, deca means 10, right? Decade is 10 years, etc. And a radius of 9.5 inches. You're going to want to sketch that out. What's the area of the tabletop to the nearest square inch? Once we do all of those calculations, I will use those to explain this reasoning part, which says, suppose the radius of that regular polygon is doubled. How does the area of the polygon change? Okay, and when you see me plug it in, you'll understand it. But very first thing you're going to do is do this got it problem off camera, and then unpause the video to see. So first I'm going to suggest you sketch it out. You figure out what that central angle is, fill in all the numbers, find the apothem, find the perimeter, and plug it into the formula. Okay, so pause the video, take as much time as you need to do that, and unpause it when you've found it. the rare kid that's actually doing that is inevitably my kid who's going to be scoring really well. If you're not bothering to do this because you're like, oh, that sounds like a lot of work, I'm just going to watch it. Okay, watching somebody do a backflip is not you doing a backflip. Doesn't mean that you can do it. You need to know that you know how to do it. So you're going to attempt it right now. Pause the video, solve this problem, then unpause it. Pause it now. Okay. So if we have a decagon, and essentially what I'm going to do is I'm going to say, instead of making the whole decagon, I'm going to make this one side of it right there. Okay. Now, if there are 360 degrees all the way around here, then this central angle is 36, 1/10 of that, right? Okay, and what they've told us is that it's got a radius of 9.5. The radius goes from the center to the vertex, so this is 9.5 inches here, okay? Now, if we were to drop an apothem down right here so that we formed a 90-degree angle, then we'd split that central angle in half, and what we get then is this triangle right here. We get that. And now that angle up here is actually only 18, half of the 36. And we know that this is 9.5. So the first thing we want to do is find the apothem, this blue length right here, okay? So compared to this angle right up here, which two sides do we have? Well, we have the adjacent side and the hypotenuse. Adjacent and hypotenuse is cosine, so we can say the cosine of 18 degrees equals the adjacent side, A, over the hypotenuse, 9.5. And multiplying both sides by 9.5, we would get the apothem is equal to 9.5 times the cosine of 18 degrees. And we're going to hold that in our memory banks here for just a second. It's not a solution. That's just a piece of the information that we need. That's the apothem length. Okay. Now, doing it again, and by the way, I'm going to recopy this. Let's see if I can copy this. Sorry, I'll just redraw it. Okay, I'm going to redraw it again with this length here. Whoops. Okay, and now we've got that right angle here. And what we're looking for, let's call it x. We know that this is 9.5. And again, we figured out that that's an 18-degree angle there. So what two sides are you dealing with in terms of this 18-degree angle? You're dealing with the opposite side and the hypotenuse. Okay, and opposite and hypotenuse is sine. So we can then say that means then the sine of 18 degrees equals that opposite side over the hypotenuse, and multiplying both sides by 9.5 to solve for x. We have 9.5, sorry, there's 5 times the sine of 18 degrees is what x is. Okay? Now, we know this. We know that this is half of a side length. So we have to double this, right? We say 2 of those for every side, and there are 10 sides, so we have to take this amount times 20 to get our perimeter. So if we say, okay, so then if we write the area, and by the way, this is an edit. Andrea let me know that I had made an error, so I've gone back to change this video and fix the error. So the area is 1/2 the apothem times the perimeter, okay? And let's fill in these values then, okay? We know, and it's a little bit, I'm a little short on space, so I'm going to just say this is equal to 1/2 times, what do we have as the apothem length? 9.5. This is down on the bottom. We just calculated 9.5 times cosine of 18. Okay, times, and now we need to figure out what the perimeter is. And the perimeter, of course, here we have x for this amount, but that's only 1/2 of a side length. So 2x is actually the side length, okay? So 10 sides, each 2x, that's 20x, okay? So we have to do times 20 times, and I'll put it on 2 lines, but it's all multiplied together, times 20 times, and what is x? It is 9.5 times sine of 18. Okay? And of course, this is one big long set of calculator moves. So we say, I'm going to say 0.5 or 1/2 times 9.5 times cosine of 18. And you'll see that your calculator opens parentheses here. You need to close the parentheses. There's a button for that above the 9. And if you don't close the parentheses, it's going to calculate the cosine of all of the things that you type after it. Okay, so we say cosine of 18, close it, times 20 times 9.5 times sine of 18, and close that one too to get in the habit of always closing your parentheses. And when you hit equals, you get approximately, because it's not perfect, approximately, it says to the nearest square inch, so approximately 265 inches squared. Okay, Andrea, thank you for that correction. Really appreciate it. Okay, and then they're asking here for part 2, the reasoning. Suppose the radius is doubled. How does that change the area? Well, remember, if you know that a length in one direction has a scale factor of 2, then once you turn it into area, which is units squared, you square that scale factor. So since you're doubling it, or times 2 for one dimension, then 2 squared is 4 times the area when you do it to 2 dimensions. Okay, so the answer for that one, and I can type this out, is if you double the length, if you double the, let's say the distance, or I guess we'll say length in one dimension, then you get an area 4 times the original, because it is now 2 dimensions, so you square the scale factor. Okay, and if I don't have room, yeah, that's good. That's the answer. Let's keep going. Okay, to do the last problem, we need to come up with this new idea. It says, suppose you want to find the area of triangle ABC, but you only know the measure of angle A and the lengths of B and C. So that's 2 sides in the included angle, like this last slide just said if you read it to yourself. Okay. To use the formula 1/2 base times height, we have the base, but we need to know what the height is. Okay, you can find the height by using the sine ratio. So here, if we know what C is, we can say, okay, here we're using the sine of A equals the hypotenuse, sorry, the opposite side, H, over the hypotenuse C. Okay, sine of A is the opposite side, H. This for this little triangle, we're looking at just that little triangle on the left to find that side length of it. which will be the height of the triangle. Okay, so sine of this angle equals the opposite side measure h over the hypotenuse c. And that's what they write here. Now solving for h, you just multiply both sides by c, and you say h is equal to c times the sine of a. Okay, so if you substitute that in for 1/2 base times height, you get the area is equal to 1/2 b times c times the sine of a. Okay, 1/2 this times the sine of this. And again, that's because c times sine of a is equal to the height, which we just did there. Okay, again, the sine of this angle, sine is opposite over hypotenuse. This is the opposite. That's the hypotenuse of this little triangle on the left, h over c. And then solving for h, you just multiply both sides by c, and you get the height is equal to c times a, or c times sine a. And that's what goes in for height. Okay? This completes the proof of the following theorem for a case in which angle A is acute. Okay. The area of a triangle is half the product of the lengths of the two sides and the sine of the included angle. That is the formula we're going to use right now, okay, for side angle side. So let's apply that to our very last problem. All right, what's the area of the triangle? And again, we have that formula. Area is equal to 1/2 the side length times the other side length times the sine of the included angle. Side length, sine of included angle. Okay, and you just plug them in. 12 times 21 times sine of 48, and blammo. It spits out a number. If we round it to the nearest square unit, it is about 94 square centimeters rather. Okay, that was just that easy. So what is the area of the triangle? Round your answer to the nearest square inch, and here is the triangle. Use that same formula. Pause the video right now, solve it out, and come back and check your answer when you've done it. Okay, so we want to write the formula down that just the area of this triangle is going to be equal to 1/2 times one of the sides given times the other side given times sine of the angle given, or 1/2 times 16 times 10 times the sine of 34 degrees. And this is just simply a series of calculator strokes. Okay, so I'm going to turn on my calculator. I'm going to say 1/2 times 16 times 10 times sine of 34. Please always close your parentheses in case anything comes after that before your equals. And we get 44.7 something. So I'm going to erase this and actually say is approximately equal to, because it says to the nearest square inch, 45 inches squared. Okay, that's how you do it. That one, though, this is an easy one. The 1/2 side times times sine of the included angle to get the area. And notice earlier they said for acute angles or acute triangles, once you make your sine cosine values greater than 90, you start getting some different numbers which we haven't dealt with, and I think that's why they're leaving it off for now. Okay, anyway, that's it. Good luck. Rewatch any parts that you need. Do the practice as needed. The book problems, I don't think there's IXLs for this, and ask me any questions that you've got. Good luck.